These next tangent and cotangent problems have phase shifts. So let's continue with our normal process. Our amplitude is 1 here because the coefficient is 1. Our period is pi divided by b, or 2 pi. Our horizontal shift is negative c over b, which is negative pi thirds times 2, so negative 2 pi over 3. Now, negative 2 pi over 3 isn't on our graph, so I'm going to add our period to it because we'll need that to be on our graph, and that would be 6 pi over 3 minus 2 pi over 3 for 4 pi over 3 being an equivalent phase shift. And then our k is up 1 from there. So let's draw our equilibrium line. We can move to 4/3 pi. 4/3 pi, and this is here. And tangent starts at equilibrium. Now, if we wanted to move another full period left or right, then that would give us another equilibrium point. But I'm going to move half a period left and right, so 1 pi left and 1 pi right, and that will give us our asymptotes. So that was what it said here. We want to move half period left and right to graph the asymptotes. So those are asymptotes. If we graph another pi to the right, that would be about there, would be our next equilibrium point. Now we have graphed our equilibrium point, our asymptotes, and now it's a matter of graphing our inflection points. There is one of our inflection points halfway between the equilibrium and the asymptote, and because the amplitude is 1, it's up 1, and because it's tangent, it's up instead of down. Same thing over here. We're going halfway between the the asymptote and the equilibrium point is here. And because it's tangent, we're going down 1, and this is what our graph will approximately look like. We can continue this process over here. Now, I'm not 100% sure that that's exactly where that would go, but this is a good approximation of what the graph is going to look like. One more. Our amplitude is 1/2. Our period is pi divided by b. Our horizontal shift is negative c over b. So that's what? 2 pi over 3 divided by 2, or pi over 3. That'll work, and k is -1. So let's graph our equilibrium line at -1. Because this is tangent, we'll find our horizontal shift is an equilibrium point. Now we move half a period. Half of pi over 2 is pi over 4. So if we move pi over 4 to the left and right, that gives us our asymptotes. If we continue moving another whole period to the right, that'll give us more asymptotes to graph. These are supposed to be not at 2 pi, but 2 pi plus like a sixth pi or something like that. And these are our equilibrium points. Now we can draw our inflection points, which are halfway between the equilibrium point and the asymptote. Sorry, that is a wrong point. It should be lower because the amplitude is 1/2. And they're rising because this is tangent. And once we repeat this enough times, that will be our full tangent graph. So this is an acceptable final answer for what our tangent graph is going to look like. A little sloppy, but certainly the right idea.